we have already finished configuring the customer side, and now we are going to start from the provider. As I said, the VRF interface is nothing but the interface towards the customer that needs to be in a different virtual router, not on the default routing table. I need to put it in a different routing table. So
Right.
we need to assign IP address after removing this F00 of the customer interface, facing interface, from the default and assigning it to into a virtual route. So otherwise what will happen is, as I said, it gets removed when you assign the interface from the default to the VRF. So keeping that in mind, I'm not going to configure I'm not going to configure the customer facing interface now. MPLS label range. Yeah. So this is the command to set the range of
Yep.
label.
Yep.
So I'm going to say MPLS label range is from this 300 to 399. This is Lubeck, and this is the inside provider interface. Autonomous
Okay.
system is 20, and then the neighbor
Neighbor.
is 6.6.6.6, and the local is the AS. No change. We are not going to advertise any network from here. Right, there is
And
nothing.
from 10 to 00 and route of 4.
Come again?
Is it using any routing protocol between those two?
Repeat again, please.
Is it using any routing protocol between router 3 and router 4?
Yes,
Where?
we are going to do OSPF there.
Okay, that's what I was asking.
IBGP between R3 to R6.
Right.
So this is router 3 configuration. Okay. Now next is router
4.
6. Let's
Router
finish
6 up.
6. F1/0 is 56.6.
In the labor range also.
and BGP is 20, neighbor is 3333, and we put this on router 6. It is done. Now next is on 4 and 5 no BGP, so I can totally remove the BGP portion, and router 5 range is 5 and 5 for MPLS, and then F1/0 is 56.5,
Alright.
and F00 will be 45.5. That's all. No BGP, only OSPF.
Right.
Oh, one more thing I forgot to do it on router 3 and router 6 is enabling MPLS on the interface.
MPLS, yes. MPLS IP. I don't need to remember myself.
This is on router 5. Now I'll also go back to router 6 and say interface F1/0 MPLS IP. And you will see MPLS adjacency, LDP adjacency, neighborship with R5 now. 1, 2, here you go. Very important thing that we need to remember is this address is the router ID of MPLS, and that is pingable from here. If this is not pingable, MPLS cannot form neighborship. The router ID of MPLS need to be a pingable address. That's why I run OSPF on R5's Lubeck. Now let us go to router 4. Configuration is like this. 4, 4, 4, and this is F0/0 is 34.4, and F1/0 is 45.4. And that's all.
MPLS IP is there? Okay, it's there. Okay, never mind.
This goes on router 4. And on router 3, interface F1/0 MPLS IP. That's all. So I'm hoping that everything is done.
BGP should come up.
Yeah.
There it is.
No, this is
never
LDP.
Mind. LDP, yes.
And I'm waiting. Ping 6.6.6.6 with a source 3333. Okay, then BGP should work. Show IP BGP summary. Okay, what about router 6? Show IP BGP summary. Okay. I think I forgot to say update source Lubeck 0. Router
Yes,
BGP 20 neighbor. I said next up self, but I did not say update source Lubeck 0. I need to do it on.
Yes, it.
But you have to do it on both sides.
Both.
Because it is TCP, if you do on one side, it will come, but you should do it on both sides for proper result. Good. Now, what is next? See, there is no VPN. There is no VPN. So VPN, when we say VPN, it includes the tunnel as well as virtual routers. Only the virtual routers will be using the VPN. The physical paths, the service provider network should not use VPN, which means the global routing table should not use VPN. So who uses VPN? The VRF tables are going to use VPN to send the routes from R3 to R6 and vice versa. So VPN will always go with VRF.
Yeah.
That's why the other vendors, some other vendors, they don't do separate command. They call it as VPN instance. The command will be like VPN instance. It's not VRF. VRFs are called as what? VPN instance. In the other vendors. The other vendors.
And there's something. I have a comment.
Tell me, please.
It's not exactly not related to this. I noticed on some new Cisco router, you cannot use the command on the switch. No, some new Cisco switches, you cannot use the command and to make a trunk interface switch port trunk encapsulation .1Q. It's gone. It's not there anymore. And then when I was reading, they said it's because it is the industry standard. They just, once you're in this switch interface, that's the mode it's going to be. You can't, it's just there. You don't have to use it anymore.
Yeah, it's true. It's true. It's for more than now 20 years. It is like this. So encapsulation .1Q, switch port trunk encapsulation .1Q. It's not. It was a mandatory command in some middle versions, but in the newer devices, we don't have ISL anymore. It's only one .1Q. So .1Q, because it's the only one it is available, you no need to worry about the
manual configuration.
Yeah. So let's now get into this.
I know.
Mm-hmm. Let's continue. Here we are going to have VRF first, and then VPN. Let's do VRF first. On router 3, I'm going to say IPVRF. I'm going to give a name, cust R1. Cust R1 and customer R1 and R2 are same company in two different locations.
Yeah, but what's the difference? What's the difference between IPVRF and VRF definition?
Okay, see, there is a command called VRF definition where you can also enable IPv6.
Okay.
For the address family IPv6. Fine. Now, I'm saying IPVRF here, and I have given a name customer-R1. This name is locally significant. R2 is also the same company. R1 and R2, they belong to same company in two different locations. But the name doesn't need to match, not necessary. It can be different. And then route distinguisher, also locally significant, I'm going to keep 1:1. There, I may give something else. I may give 2:2. Now, what is the use of route distinguisher? If you have more than one VRF, meaning if you have more than one customer connected to same router 3, to know which customer's route we are learning, we need an ID. That is why it is called as route distinguisher. Now, next is the route target. Route target, whatever you give here is going to be the community value to identify all the routes that is given by R1. All the routes of customer R1 is going to be identified with one single numerical tag called route target. And this route target, you can have separate value for export and separate value for import. Or if you wish to have for both same number, I can use the same number. I'm going to use same number. I'm going to say, I can also use the same number like what I give for route distinguisher. But there is no connection. It need not to be same also. I want to say that one very clearly. This is different, that is different. That is the routing table identification number. This is the customer routes tag. Now, I did not say export and import. If you don't say that, it is going to be for both. And let us verify these things. Show IPVRF detail will show you that you created a VRF called customer-R1. And this VRF ID you didn't give, it is by default, it is taken. If you want to give, you can give it. So if you want to give different ID, you should say IPVRF, and you will see ID here. In this version you don't have, but in XR and all we have the option to say what ID.
Right.
Now, what is the use of that ID? Smaller the number, first it gets processed. You understand? During the process time, it processes the one with the ID smaller, and then it goes to the next one. Now, route distinguisher, we gave 1:1, it is there. And route target, if you see here, community value for export and import, it is taking the same thing. Because we did not mention import or export. I told you if you don't mention, it's going to be taken for both. Done. Now, what is next? Next will be there is another command. Okay, let me show in this command itself. You can see that this has got route distinguisher, this has got route target, but what is missing is interface. You can also see this in a small table without detail. When you hit enter, you can see it has got the route distinguisher, but you don't have interface. So let us assign interface now. Interface F00 IPVRF forwarding, for which VRF, for which routing table, for which virtual router, customer one virtual router. This is the virtual router's name. And now we can give IP address 13.13.13.3. Now you can say no shut. Okay, so we got a new router, and in that new router, this interface is a member. And now if you see that in the routing table, show IP route, you won't find F00 anywhere in the routing table. Do you see any F00? There is no F00 because it's not a member of this global routing table. It's a member of VRF routing table.
Something to duplicate.
That doesn't matter, you know. It's a mismatch in the duplexes of duplex.
Oh, duplex.
Because we are using different hardware version. You remember on R1 we are using security operating system. R3 we are using enterprises version. So there is some mismatch in the duplex. That can be fixed later. We'll do that later. Now, sure, you want to fix it now? I can fix it now. What does it say? Duplex mismatch discovered on F00, not a half duplex, whereas R1's F00 is half duplex. So security box is saying I'm using half duplex. This guy is saying I'm a full duplex. So what do you want? You can make this as a half duplex, or you can go to R1 and make it as full.
Yes.
Okay. Now there is no more problem. The problem is fixed. Now, if you want to see the routing table of the virtual router, we can say this command show IP route VRF in a virtual router. Name is customer
-R1.
-R1. This is it's a separate routing table. You see, it clearly says this is the routing table of the router called cust-R1. Now, if you want to ping, by default, it will ping using the default routing table. So you will not be able to reach R1 by using default routing table. You need to reach the virtual routers routing table. So when you ping, you need to ping with VRF cust-R1 13 dot. Now only you will be able to ping. So you're sourcing your traffic with VRF routing table, not the global routing table. You're sourcing with VRF routing table. Without that, if you try pinging, it will try to source from the default and the ping won't happen.
Right.
Okay. Now I'm going to do BGP now. BGP by using what? Default routing table? No.
BRF.
Okay. So how do we do that? Go to router BGP20 and then say address family IP IPv4 for VRF cust-R1. So we are now inside the routing table of virtual router of customer BGP. So this is not a global BGP. This is the BGP of customers routing table. You got this line clear?
Yes, sir.
Now I need to say neighbor 13.13.13.1 remote AS 10. That is all. I'll be able to learn routes from R1 via eBGP relationship. You see, you can see that there's a neighbor via the, see, we did not create VPN. I was telling you, wherever VPN, there will be always VRF. So wherever there is VRF, there will be always VPN. So we don't have VPN, but we are still seeing that VPN VRF. So that's how they have they designed the logs. They know very well that this VRF you're creating is for VPN. Okay, now let us go and verify the routing table. Show IP route. What is the command to see the routing table of the customer?
Still there?
I'm sorry? I want to see the routing table to verify whether 192.
Show IP VRF. IP route VRF.
Yes, IP route VRF cust-R1. I can see here via eBGP relationship I have learned 192.168.0.0 network. Cool. Now this I need to pass it to R6 via the tunnel, isn't it?
Yes.
Yeah. So let us first of all create a tunnel. Between R3 and R6 we are going to create tunnel. How do we do that? Router BGP20.
Let me ask a question. Since this route is already in BGP, can R6 can it be seen by R6 without a tunnel?
No.
Okay.
You remember, VRF always comes with VPN. Even in the log you saw that, right? VRF VPN session is up. The VPN is mandatory. See, whatever you learned in the virtual routing table, it cannot go into the physical link. Why? It is not a part of physical link. Is it a part of physical link? Is the virtual router a part of physical link? No, we have totally isolated it, isn't it? The physical link F01 of the provider router R3 is not a member of virtual router. So how do you expect the routes that are learned via a virtual routing table to pass through the physical default routing table? Not possible, right?
No.
You need a tunnel. Mandatory. It's mandatory. Without tunnel, not possible. So let us form tunnel now. Address family. See, the command is not IPv4, it is VPN v4. Earlier, listen carefully, to enable BGP under VRF table, we put the command IPv4. That is for the VRF member. But now we are not doing that. We are doing VPN. So the command is not IPv4, this is VPN v4, unicast. And then we need to say neighbor is 6.6.6.6 activate. You already have a neighbor. You are just activating a VPN session with that neighbor. Yeah. So let us go
Right.
to R6 also and do the same. Address family, VPN v4, unicast, neighbor, activate. Now you will see another session. Okay. So,
All right. So okay. Question. We only use activate when we have a VPN v4.
yeah.
So if say for instance we are under the address family IPv4, do we need activate?
No, under the IP address family IPv4, it is not activating. It is forming neighbor.
No, I'm asking this question because I was looking at a configuration at work that was there way before me, and so we are the customer, so we are the CE router, and they have activate, and I said, why are you putting activate? And they say, oh, that's how it always been.
What? That is what? Where are they activating?
That's how it always on the IPv4.
Why are they activating it? It is by default they are active.
I don't
Maybe they might have
exactly.
disabled it and they are activating it. They are doing waste job. After disable, they might have cancelled it saying no address family IPv4 unicast earlier.
No, they didn't do it. It's a brand new router. The router
Then
just
there is
been
no
installed
there
a
is no
week
point
ago.
of activating. It is by default activated.
Right. Because I even showed the guy that I said, do not put activate, and the BGP session came up. But they said, oh, we gotta put activate. I said, okay,
Maybe
go ahead if you want
they
to,
are
but it's
following
not the
Arabic
right
book.
thing.
They are not using their brain. They are strictly following the
Maybe.
Arabic book.
Right.
Without understanding, when you do labs,
Okay.
that is what will happen. You need to have proper understanding when you do something. They did not really learn with understanding.
Yes.
Fine. We have now the VPN also, but we will not be able to learn anything in the VPN now. Why? Because we do not have the import value to import here. Do we have any VRF here? No. Whatever comes in VPN will be downloaded in which table? VRF table. Virtual router. We don't have a virtual router.
Yes.
You see, show IP VRF, nothing. Show IP, show BGP, VPN v4, unicast all summary. I do have a VPN neighbor, but nothing learned from that neighbor. Why? Because you don't have VRF. Let's go and configure VRF. IP VRF cust -R2
Costs are too.
route distinguisher. I can give the same number or I can give different number also. And then route target
Two
should
that is
be
fine.
same like what you exported. I exported and imported using 1:1. Here also I'm doing the same. Now the interface of the customer is F00, IP VRF forwarding cust
Cost.
-R2, no
And then
shit.
R2.
IP address is 26.26.26.6. 255.255.255.0. Now, after saying this, will I be able to see something in the BGP table? Let's go and check. You see, earlier I was not seeing, but I can see now one prefix learned. What is that prefix? 192.168.0.0 coming from R1. How do you know that? You can know it by typing this. You
Yes.
see, 192.168.0.0 is coming from router 3. And there the route distinguisher used was 1:1. Here the route distinguisher used is 2:2 locally. Okay, now it's coming from autonomous system number 10. Now, you can also verify by typing this command show IP route VRF cust -R2. You can see that this is learned through IBGP. But you don't have anything learned from R2 because we don't have BGP neighborship with R2. We don't have BGP neighbor with R2. Did I configure? No, you see, I don't have BGP with R2. So let's go and configure. Show IP BGP, you don't have any configuration with R2. Show IP BGP summary, you don't have anything with that. Okay, let's also fix this duplex issue. Let's go to R2 first and say, hey, you be a full duplex because it's keep on coming now. Let's stop it. What is the command? Okay, now we are in R6. We'll go and say router BGP 20 IP VRF. Sorry, IP address family IPv4 VRF first hyphen R2. And then we say neighbor is 26.26.26.2. Remote AS is 30. Here you don't say activate, here you say only this. And then VPN is already done. Let's now go and verify. Show BGP VPN before unique assault. Now you can see both eBGP and iBGP. You have also learned one network from your eBGP. You can see that by removing summary. You can find it here. Under the route distinguisher 2:2, you have this. And this is a learned one from R3. This is learned from eBGP. This is learned from iBGP. eBGP learned when we'll have local professor.
One moment. In front of this 192.168.0.0 from R3, there's an I after valid and best.
It's internal. It's internal.
Can you explain, please?
It is internal, meaning it is coming from your own iBGP neighbor. You see, it is not there. See, it's internal. It's called internal. You see here. For eBGP, you won't find. Whatever you learn from your iBGP neighbor, you will see I there. Okay. Now let's go and see. You will see the opposite here. You will see I for this network on R3. You want to see that? Let me show you. Did you get what I'm saying? You see, you will see I for iBGP learned, but for eBGP learned you don't see.
Those two. Right.
Yep. Now, what is next is we are expecting route on R2. Let's check in. Show IP route. You will see the subnet coming from BGP10. Try pinging this. Ping. No need to put any VRF here because this is not service provider router. Now, source, Lubeck. If I'll be able to ping, then everything is good. If not, there is something to troubleshoot. Troubleshooting is a fun. Let's do that. Okay, why am I not doing? I know why it's not pinging. I know why it's not pinging. Tell me why it's not pinging, if you can. Let's go to router 1, show IP route. Do you have the route to reach that remote? Yes, you do. Yeah. Likewise, if you check in R2, you have the route. When you have the route, and if the ping is not happening, the problem is with the ISP's underlay, not the overlay, not the tunnel. Tunnel is good. That's why you are seeing the update. You got it? The underlay is the issue.
Yes.
Let's see what is wrong with the underlay. Go to R6. Show MPLS LDP neighbor. Do we have MPLS neighbor? I do. Go to R5. Show MPLS LDP neighbor. I do. Show MPLS LDP neighbor. I do. So the router ID that is used here is 3333. What about this one? The router ID used here is 6.6.6.6. Now we need to check whether the same router ID is used in BGP. Show IP BGP neighbor. What's the router ID of the neighbor? 3.3.3.3. Go to router 3. Show IP BGP neighbor. What is the router ID you see here? It is 6.6.6.6. That's cool. Now MPLS is also good. This is also good. What about OSPF? Show IP route. Sorry, show IP protocol. What is the router ID that OSPF uses? 333. Show IP protocol. Cool. So there is no issue. We should ping. We are not pinging. We are not pinging. We are not pinging.
Look at the IP address on the loopbox.
On this loopback, it is 192.168.0.1, and on router 2,
no,
so I'm going to say ping
2, yes.
this one with a source of it's okay. We need to troubleshoot. Troubleshooting is good. Let us go to router 6 and see whether MPLS is working fine. Show MPLS forwarding table. And for 3.3.3.3, the MPLS is using a label. And for, I got it. You see, there is a label for this network coming from the right. But there is no label, there is no mention about the network coming from the remote. Show MPLS forwarding table. Here we have the local one. So when I say show IPsif 192.168.1.0/24, oh, I need to use VRF. IPsif for VRF cust-r1. Oh, label is there. Label is there. You see, there is a transport label. There is a transport label. There is a service label. Service label is given by the VPN 605. Transport label is given by next router. It is good. Do you see what I'm saying? This is transport label. Go to the next one.
Yes.
This is the final
I see.
tunnel endpoint. This is service label, VPN label.
Right.
When you capture MPLS, when you capture the packet, you'll see two headers. One with this label, bottom of a stack 1. This one, bottom of a stack 0. I'll capture and show you it later. Let us see why I'm not able to ping. We need to fix that problem. This is not appearing like a problem, but it is coming as a problem. How is that possible? Everything looks good. Let's go to router 6. And this is R2. And this is 0. And here I see everything fine. I see everything fine. This is a VPN label. Service label. This is the transport label given by R5. Come on, what happened to you? You look good.
me. Can we
No,
try
we don't
pinging
have any
from
network advertised.
R3?
We should only ping from
Okay.
this customer. Ping 192.168.1.1 with source 192.
See what that
Let me debug, or let me do one thing. Let me sniff the packet in between R3 and R4. Okay, now ping again. No, packet is not even coming here. Packet is not.
It's because the image is a secure image.
Security image is in the customer side. That doesn't match.
Okay.
That doesn't matter. R1 and R2 has got nothing to do with VPN or MPLS. It's a normal router. It needs to send the packet out.
Okay. Yes.
So there is some issue with R3 and R6. Sometime, when you restart, it will be working fine. I'm going to do a quick restart. Before that, I want to save all the routers. All right, so stop all the routers in this provider side and start one by one.
Go up to the idle PC.
Okay, now let's go to check the routing table on R1. We're waiting for the BGP update to come. Okay, next stop may not be reachable for the neighbor. Not 36. What? 6.6 not 32 mask. How is that? Show IP. Show run interface loopback 0. Ah. Okay. Okay. Interface loopback 0 IP address. Yeah, tell me please.
I wanted to see if that was
It was
also
24 bit.
24 bit or 32 bit. Okay.
Okay, now what is next? But okay, LDP has come. Now only every process starts. So I'm quickly expecting some good output here. Okay, I received one prefix here and also here. Show IP route. I am seeing that, and let me try pinging. And look at this, it's pinging. So it's only a restart, nothing more. Right? It's not subnet mask and all. It's only restart. So let us now sniff and see the double layer MPLS header. Okay, so before that, I want to go to router 2, router 3 and show you the CIF, show IP CIF for 192.168.1.0/24 0/24. This is for VRF cust -R1. Now you see, these are the two things I'm expecting in the Wireshark. Let me ping and show you. 403 and 602.
Okay.
You see there are ICMP packets. Now this is going from where? This is going from router 1 to router 2. Look at this, 403 and 605.
Right.
Is it the same thing that
Yes.
I showed you? Yeah, 605. So
Right.
that 605, if you see, the bottom of the stack bit is on, which means this is the last layer. And for 403, for the transport layer, layer of MPLS, you see 0 here.
0.
Right. So what is next coming is we are going to add more customer to the same PE router, and we are going to have multiple IGP routing protocol instead of BGP between the customer and the provider. Right. After that, we are going to do some more service provider related learning of MPLS if you are okay. Um, okay,
Yes, I'm good.
enterprises level is just do layer 3 VPN, boom. But service provider track involves layer 2 VPN and traffic engineering with RSVP, T, a lot of things like that. All right, so you're not just learning CCIE enterprises, you're also learning CCIE service provider. That will be a complete learning. So that's why I'm going to give you that.
Right.
Do you have any questions?